Assalamualaikum and hi. Today we are going to present to you a chromatography in industrial usage, sugar analysis. We are from class AS1142E1. Before we start our presentation, let me introduce you to our presenters. First, me myself is SHAQEER FAZRIN bin AZIZON. Then we continue with MOHAMMAD ZIKRI bin MOHAMMAD Isa. Then we have MUKHRIEZ Daniel bin ZAHARI. QAYYIM KASYFUL bin ISHAK, then we'll finish with by HANZALAH IMAN bin HAMIDI. So in this presentation, we will share to you what is chromatography. Then we will continue with the theory of chromatography and how it is connected to sugar analysis. Then we have a procedure for sugar analysis using chromatography technique. Then we have HPLC advantages, then ended with a reference. So what is a chromatography? Chromatography is a separation technique that we use to analyze complex mixture by passing them through two phases, which is a stationary phase and mobile phase. Chromatography allowing scientists to identify and quantify them accurately. Chromatography also used in various of fields, for example, in chemistry, pharmaceuticals, and environmental science. So what is the type of chromatography? We have three types of chromatography. First, we have a gas chromatography, GC, then we have a liquid chromatography, LC, and third, we have a thin layer chromatography, TLC.
I am going to talk about high-performance liquid chromatography in food analysis. High-performance liquid chromatography, or abbreviated as HPLC, is a type of partition chromatography. This method is used to separate, identify, and quantify each component in a mixture. It relies on pumps to pass a pressurized liquid solvent containing the sample mixture through a column filled with a solid absorbent material. HPLC is used in various ways, such as manufacturing pharmaceutical products, detecting drugs in athletes, and also analyzing and quantifying sugar in a sample of food. Now I am going to talk about sugar analysis using HPLC. These are the components required to run a HPLC: a solvent reservoir that acts as a mobile phase, a pump to produce higher pressure, a sample injection that will be used to inject sample, a column that functions as a stationary phase, a detector, and a computer system. Here are the steps of doing sugar analysis using HPLC. First, assemble our equipment according to a certain standard method that is used in analytical science related to food. For example, in this procedure, we follow the standard of AOAC International 22nd edition 2023. Next, put each of the different sugar samples from different food samples in a small vial and it is now ready for the analysis process.
For the next method, select the mobile phase where the analyte will be dissolved in it. Mobile phase will push the analyte through the column. We use acetonitrile and water as it is very polar and allow the sample to dissolve in it. Then put a suitable column in a pressure. Column is a component that are cylinder shaped, made of stainless steel, contains material primarily nonpolar hydrophobic amino particles that are needed to form the separation. As the analyte and the column is small, it needs more pressure, which is provided by pressure. This is the particular video about how to put a suitable column in a pressure. This is a HPLC. HPLC is a reverse phase chromatography. The mobile phase is a polar solvent, which is water and acetonitrile. Passes through the stationary phase that contain non-polar material. This is in a stationary phase that are explained about how the HPLC will be occur. Each type of sugar has its own polarity and react differently with amino particle. For example, fructose is more polar, so it will not bind with the non-polar molecules of amino and it will be passed quickly through the stationary phase.
The instrument will then do the separation process. Next, pressurized solvent carry the analyte through the column. In column, interaction happen between mobile phase and stationary phase. Strongest binding molecule elute lastly, while the weakest will elute first. For each analyte, there are specific time indicators where analyte have been eluted from the column. These are what called retention time. Retention time is the amount of time a compound spends on the column after it has been ejected. If a sample containing several compounds, each compound in sample will spend a different amount of time on the column according to its chemical composition. For example, from this table, we can see that fructose retention time is 4.056. If the graph show a peak at the 4.056, that means that fructose are in the sample. If they are not, then fructose is not present. The higher the peak, the higher concentration of fructose or a said sample. Effective index detector will detect the sugar, which can measure ability of molecule to reflect light beam. These are components in the detector. The light beam that reflected will be converted to electrical signal that a computer can read. The computer will generate chromatogram illustration, which consists of a plot of retention time and intensity of each analyte. Each analyte have different specific peak, so that we can determine the identity of each analyte, and their concentration can be calculated by calculating area of under the graph. These are examples of a chromatogram. We can see four graphs here. Graph A is standard solute containing indicated sugar for fructose, glucose, and sucrose. B is sample from a ripe Heinz tomato 1706. C is sample from unripe Heinz tomato 1706. D is a calibration curve for glucose and fructose. If we can see clearly, we can notice that ripe tomato has higher peak on fructose than unripe tomato, which means that ripe tomato have higher content of fructose, and both of them did not have peak at 9-minute retention time, which means that both tomato did not have any sucrose content in it, unlike in the standard solute.
Hello everyone, my name is HANZALAH bin HAMIDI, and today I want to share you about HPLC. Well, HPLC stands for High Performance Liquid Chromatography. Well, it is used in separation and identification in analytical chemistry. But before we move on, what is actually chromatography? As to make it sound easier for us to understand, HPLC is like a special machine that can help scientists look at tiny things in a mixture of liquids. It's a bit like using a strainer to separate different things in your soup, but much more precise and scientific. Okay, now that's a brief explanation about HPLC. Now, we want to know why HPLC are often compared with gas chromatography. Well, it is because they are quite similar and not at the same time. What is the same is that both of them work by the principle of illusion, a chemical process in which solvent extracts a substance from a mixture. Both of these techniques depend on the same general method of phase movement, sample detection, and chromatogram analysis. Uh, they were both of them exist for a different reasons. They are used to analyze different states of matter. Like HPLC cannot use to analyze gas and vice versa. Well, this is a picture of HPLC machine that are small and can be stacked on the table. Now, we want to know the comparison of HPLC and gas chromatography. HPLC are more faster than gas chromatography because they use pressure. Uh, they use pressure. Unlike gas chromatography, they use only oven, and it does take time to build up heat. Then HPLC save spaces while gas chromatography don't because HPLC have smaller columns and a smaller machine overall. They can save space better because gas chromatography machines are way bigger. HPLC can handle many of the compound. Meanwhile, gas chromatography don't because they can handle any soluble compound regardless of volatility. gas chromatography can only analyze volatile substances. Well, and that's, in the last picture, it explains about a picture of laboratory gas chromatography machine and all of its components. They take up a big space. Yes, can you? If we can make a comparison between the picture previously and this picture now, it's pretty big, you know. Okay, that's all for me. Thank you very much. Well, this is the last part, which is the references. As you can see here, we have five references, which our team has been doing all deep dive to gather all of this information. So I hope you can gain a lot of information based of our presentation. Thank you very much, and I hope you have a nice day.